So this last one, let's just take a look at where I screwed up, and I don't know why I screwed up, but so once again, I know that something is happening here, so I just counted the vertical distance from A to B on the original graph was just 1 unit, right? 1 unit. The distance from here, maybe I'll even just do this. The vertical change from A to B, 1 unit, right? The vertical change from A prime to B primed, Neville, how many units? 3, okay? So there is a change by a factor of 3, as we've established. All right, let's take a look at this one. This was all about vertical and horizontal, so probably this is going to involve a horizontal. This is the original. Again, one is not dotted, but you can kind of see. I'm going to do the original, maybe an outlined. Here's my original. It contains A and B. And the other graph has A prime, B prime. What has changed from the highlighted graph to the second graph? What's the change? Stretched out, right? So if it's stretched out, there's probably a change in the B value. And that means B is probably going to be a fraction then, right? Like a small number. So let's see what happens. Well, we'll cross that bridge when we come to it. So the horizontal, I'm going to count vertical again. From A to B, I moved up from 0 to 6. Same with A prime, B primed, right? So there's no vertical stretch. And the reason I know that, the distance from A to B is the same as the distance from A prime to B primed. So there's no vertical change. Horizontally though, let's see, the vertical distance from A to B, 1, 2, 3. From A to B, the horizontal distance is 3 units. From A prime to B primed, the horizontal distance is, I'm going to let someone else tell me. Let's see, here's my B, right? So 1, 2, 3, 4, 5, 6, and that's where 6 units. So how do I jump from 3 to 6? The distance is doubled, right? This distance is doubled. Okay, so this means the distance is multiplied by a factor of 2, right? So this is the tricky part. So if the factor is 2, if the multiplier is 2, B equals what? 1 over 2. Okay, that's it. B equals 1 over 2. A stays, there's no change in A value, so new equation. Again, it says in terms of F, so I have to keep it. So Y equals F. It's a B value, so it goes inside, attached to the X. Okay, that's it. Everyone agree? Neville? Jack? Carl? Yeah? Evie? That's it. These are very tricky, that coming up with the equation. And so usually maybe there's one on a homework assignment, like a big review assignment, or on a test. You won't get something like this on the final exam, like not the provincial exam. But it gets trickier when there's a couple of shifts and a stretch or compression, right? Because we're going to see tomorrow or Friday we might have with an A and a B and an H and a K. Those are the ones that get trickier, right? Okay, so that's it. I'm gonna give you the rest of the time, about half an hour to work. Please let me know if you have any questions on 1.4. And then, yeah, if you can get this handed in, I'll take a look at it tonight and get it back to you. So what I'll do, Eduardo, is I'll probably post a key online, and you can take a look at it online too if you want to just check your work. Hi. Perfect. Thank you. Thanks, Joanna. Just come to my desk if you have a question, or raise your hand. And if you've got some time, you can also you can read a little bit. We've already sort of done most of the reflections, but you can read about reflections too, or the combined. Yeah. Here. Well, if I actually gave you the equation, yeah, this is a cubic, but they were just testing a concept. So they're just calling this graph, they just called it f of x. They just called it a generic f of x, but it is a cubic.